Okay, so we're going to try and square root -9 somehow. So you should already know some stuff about negative numbers and some things about surds, which we're going to use to get this sorted. So let's just try out some suggestions. We know that 3 squared is 9, and that is not -9, so that doesn't work. And the -3, when we square it, is -9 or +9, which is also not -9, so that doesn't work. Anything that isn't a 3 on the number line won't get us 9, it'll be the wrong size. But as far as the number line goes, the only places we can find a 3 are there, and they both don't work. So whatever this is, it's not on the number line. But we don't need to panic just yet. We have some other things we can do. We know that 9 is -1. Sorry, we know that -9 is -1 times 9. Now this we can square root nicely. So this is 3 lots of root -1. So it still behaves like a number. And as long as we just treat -1 as a nice piece of algebra, it all works fine. So whilst it's not on the number line, we can still just not panic and use our laws of algebra and see how it behaves. And a really simple thing we can check is, does this in fact square to make that? What is 3 -1 squared? Well, it's 3 squared root -1 squared. What is 3 squared? 9. What is the square root of -1 squared? It's -1. So that must be -9. So it does in fact square to get to -9. That's all fine. So it seems to work. There are other things we can do with this. Well, we can try other things. What about the square root of -64? Well, that's going to be 8 lots of the square root of -1. So the system holds together, we're all wonderfully sorted. What about adding these? Let's try multiplying these things in fact. What about 3 root -1s times 8 root -1s? Oh, we still have our surd laws. That all still holds true. 3/8 are 24. And root -1 times root -1 is 1. Is -1. Which means that this is -24. So it doesn't seem to cause too many problems having this as a thing. In fact, it might be worth giving this a symbol. And there is a convention. We call this, we have invented or decided to use the letter I to stand in for the square root of -1. And as long as you know that, everything else you know about algebra is still true. You can collect terms, so 5 plus 3i, take 7, take 9i plus 4 is going to be, well, 5 take 7 plus 4 is 2. And 3i take 9i is -6i. That looks like a perfectly fine piece of algebra. Don't see the problem. I could even multiply that by 3 if I like. 3 lots of 2 take 6i is 6 take 18i. There's nothing wrong with that either. That seems like a perfectly reasonable piece of algebra. Nothing seems to break. We can even multiply these things together. 4 plus 3i lots of 2 plus 5i. Well, we can expand brackets. 4 times 2 is 8. 4 times 5i is 20i. 3i times 2 is 6i. And 3i times 5i is 15i squared. Now at this point, we can remember what I actually is. It's this square root. So what is I squared? That's -1. So in fact, that is really -15. We can now simplify this. 8 take 15 is -7, and 20i plus 6i is 26i. So it looks like maths all works as long as you're happy that the square root of -1 just is its own thing. I suppose I should let the cat out of the bag now. We call these numbers imaginary numbers, which is a garbage name because they're real. And if you combine an imaginary number with a traditionally real number, you get a complex number. So 4 plus 3i is a complex number. That just is a number. -2 plus I is a number. 0.38 take 4.27i is a complex number. These are numbers. They behave properly under operations. You can crunch through symbols and it all works out fine. If you care what it means, see some of the other videos that are coming up.